Afternoon, everyone. My name is Gautam Billa, and I'm Vice President of Sales Engineering at Sienna. Sales engineering. I think those words have a little bit of an oxymoron to it. It's like saying, I can give you an exact estimate of something. Well, if it's exact, why is it an estimate? Or it's like saying, there's a random pattern to something. Well, if it's random, why is there a pattern? So why do I put sales engineering in this category of oxymorons? Let me explain. I'm sure you've all been through or heard of the term life cycle of a new technology. Now, when we see a shiny new innovative technology, we talk about it, we advertise it, it triggers our sales DNA. And we advertise it in forums, there's startups that get generated, there's funding that comes in, and there's a lot of hype that generally gets created on this new technology. Now, at some point in time, we realize that the technology is not really able to live up to the expectations and promises that were made earlier. And that's the time we kind of reach the peak of this hype curve, and then it starts going back into a trough. So that's the red hype curve. But along with this red hype curve, there's also another green curve which kind of runs hand in hand. And I call this the curve of reality. This is the one that actually triggers our engineering DNA. And this is the one that's asking the question, how will this technology actually work? How will it scale? How will we make it more reliable? How will we make it more safe? How will we productize it? And all the right engineering questions. This curve progresses in a more steady state as we solve some real-world challenges. Now, when I put these two curves together, what we get is a hype cycle of a technology. And Gartner's been using this term for a long time now to actually define life cycles of new technology. Now, I started spending some time to compare some of these hype cycles that have hit our industry in the last decade or so. And while I was doing so, I realized that it's not really an apple-to-apple comparison. There's a critical dimension which is missing when we actually start to compare these hype cycles together. And I call that dimension the economic blast radius of a technology. Now, since I did coin that term, let me explain or define what that means. The economic blast radius of a technology tells us whether that technology is capable of changing a domain, it's going to change a business vertical, is it going to change a country, is it going to change a continent, or does this technology really has what it takes to change the world? So when we talk about blast radius of anything, or the way we measure blast radius, there's an epicenter, which is the focal point of impact. And then we measure from there on, what's the direct impact, what's the indirect impact, what's the collateral damage, and so on. To be able to measure the blast radius of anything, what you need is a base. For example, if you're going to be measuring the blast radius of a component failure, in this case, your base is going to be the schematic diagram of your circuit board. So you take that as a base, you plot the component failure, and then you try and measure what's the blast radius of that. Or if you're going to be measuring the blast radius of, let's say, an explosion, you'll probably do it over a map. Now, in our case, if we have to measure the blast radius of a technology or the economic blast radius, the base is going to be the entire digital economy. So let's try and map out our digital economy as the base. Now, our digital economy is actually a spin-off from what I call the physical economy. And the physical economy is usually made up of two things, B2B and B2C, the way we call it, right? So all of us as consumers here, spend north of $60 trillion annually on goods and services. That's a lot of money spent. Our enterprise IT teams spend about $5 trillion on hardware, software, services, devices, so on. And for a long time, these things have been part of what I call a physical economy. Now, the goods and services in the last few years have remained the same, but the consumption models have changed. And what do I mean by that? When we go to a new city, we all still take a taxi to commute from one place to the other. It's just that we don't extend our arm out anymore to stop a taxi. We take out our mobile phones and we book it over the app. Note that we also don't pay the driver, we pay the app. So the flow of money has also changed. And this is true for this entire consumer economy. The consumers, goods and services are now sitting on a cloud platform, and these are all accessible on our handphones via an app. We call it the e-commerce market, and it's reaching about $5 trillion globally. The exact same thing happened on the enterprise side itself as well. And the public cloud market came up, and it showed that there are efficiencies in the way we build IT services. And the public cloud market has been pulling some spend away from the enterprise spend, and it's about $0.7 trillion globally. Along with these two, there are a lot of other adjacent markets that came into picture as well. Look at the digital advertising market, about $500 billion globally. Look at the video on demand, music on demand, the streaming market, about $0.2 trillion globally. And then there's the entire infrastructure, the power, space, the real estate required to build all this infrastructure. The colo market, about $70 billion globally. So now that we built the cloud infrastructure and we put an entire digital economy together, we have our two islands. And what really is needed to connect these together is a highly scalable and reliable connectivity infrastructure platform. And that's been our service provider networks for a long time. Rough revenue about $2 trillion, and it stayed flat over a decade or so. Now, between these two ecosystems, there is the flow of data and there is the flow of money. Now, while the data always flows through the Connect infrastructure platform that we built at the bottom, unfortunately, the flow of money is not the same. It could be direct. And that's been the challenge of our industry for a long time now. But maybe that's for another day. Now that we put our map together, let's keep this as the background and get back to our conversation of economic blast radius of technologies. Now, if I start to plot out some of the hype cycles that our industry has seen in the last decade or so, I'm sure a lot of you remember SD-WAN as a technology. It did create a lot of buzz in our market a few years back. Now, if I try and plot out the epicenter for SD-WAN on this map, you see that it sits at the connectivity infrastructure layer. So while SD-WAN can change a lot of things in the network layer, what we realize is it does not, the overall ecosystem has limited visibility to what SD-WAN does. NFV, again, is a very similar technology. And if you look at, again, the epicenter of NFV is in the connectivity infrastructure layer. Let's look at 5G. 5G, again, could have a couple of epicenters here, one sitting in the connectivity infrastructure layer, which is the bigger one. It could also have an epicenter in the enterprise space because of the private 5G use cases. But again, if I look at the economic blast radius, it's limited to certain areas. Now let's talk about the current ongoing hype cycle, which is the hype cycle of AI. And we've been in this hype cycle for a few months now. If I try to plot out the epicenters for AI on this map, I could actually do that in every space of this map. There is an epicenter. And I would argue that some of these epicenters, let's say on the top right corner, the one in the e-commerce market, the one on the, let's say the advertising market, have been there for a much longer period of time. And they are much more mature than some of the other epicenters that we see at the infrastructure layer. The point that I'm trying to make is, even after the hype is over and we get into a normal productivity cycle, the magnitude of economic blast radius that this technology has is something that we've never seen in the last decade or so with any of the other technologies. So this is going to create a sizable impact on the way we do things, on the way we build networks, and so on. Now, there is a prediction, of course, that this technology is capable of creating a difference of about a few $1 trillion in world GDP. So I would argue that we could actually compare the magnitude of this platform shift of AI to the Industrial Revolution, or even something like the invention of the internet itself. It could be that big. Now that we've kind of talked about the scale, let's look at where are we in this journey of AI? Where are we in this ecosystem? I think it'll be a good thing for us to actually take a 360 view of where AI is. We'll talk about the front-end business enablers, the red curve, and we'll talk about some of the engineering drivers at the back end, which is the green curve that we talked about. Now, for any technology to be successful, I think corporate funding and backing is one of the most important things. If we look at it from a perspective of AI, the hyperscalers are pouring tons of money into this technology. The enterprises are willing to spend to consume this technology. There are 50,000 plus startups on AI and ML today. VC funding is cautious right now, but as a percentage, it's still increasing on AI. So it's a very healthy ecosystem there in terms of funding, corporate funding and backing. There are governments who are backing this technology in terms of regulation, in terms of policy, tax concessions, investments, and so on. So very solid backing from the different governments on this technology. Monetization. I think one of the most important things again, and I won't go too far, but let's take a simple example from the content industry. Now, what if you could actually create a full-length movie and you could do that without the need of any human actor or without the need of any outdoor location? You'll do that at 1/5 of the cost and 5x the speed. Think about it. Is our next superstar going to be an AI character? Possibly. Are we going to change some categories in the next Oscars? Possibly. I think the possibilities are unlimited, but almost scary. Now let's look at some of the engineering drivers at the back end. Chipset ecosystem. Again, predictions are that all the chipset manufacturers put together in terms of GPUs will not be able to meet the demand for AI. There's a lot of new investment going into this domain. Some of the Gen AI models, the sheer pace of innovation of the Gen AI models. In 2018, we saw models with about 110 million parameters. By 2020, this number was up to 175 billion. 2022, it's gone up to 530 billion. And in 2024, I won't be surprised if we see a Gen AI model with 2 trillion plus parameters. The last thing, of course, the cloud and the network infrastructure platforms. Now, this is an area where we need to solve some of key challenges in the industry. Of course, there is the energy efficiency part of it. My colleagues have talked about it. There is cooling. And at Ciena, we are spending a lot of time to redefine what will networking look like in this era of AI. Now, to conclude my piece here, when there's a technology that hits the industry at this magnitude, there's some old value which is lost, but there is a lot of new value that gets created. And when there's new value created, it gets distributed among the players in the value chain and in the ecosystem. Unfortunately, the split of this value is never fair and equitable. But what that tells us is there is an opportunity for us to reshape the industry with new business models and get a bigger piece of the pie. We already started seeing this happening in the compute space inside the data center. So in the last few months, we've seen the change in, for example, the shift from CPUs to GPUs and the corresponding change in NVIDIA's revenue and market share. It's been a huge jump, as you see it on the chart. Now that we put in so much of compute and storage inside the data centers, and once we are out of this, let's say, initial training and inference period of AI, these models are going to generate a lot of real data, and these models are going to generate a lot of synthetic data. And we know when data is created, it does not live on a memory space. Think about YouTube. You create one video, it's watched about 5 million times. So it's safe to say that data actually lives in the network. It's constantly in motion. With that, I'll leave you with two thoughts. One is, when this data starts to flow, or when this tsunami of data starts to flow from inside these data centers into our networks, are we ready to scale? And the second one is, as a networking industry, are we ready to really monetize this opportunity? Thank you.